To determine if a difference exists between the means of two independent groups, we use the independent sample t-test. In this case, we know that the null hypothesis is there is no significant difference for example, here blood sugar as the continuous variable between group A and group B, which is our dichotomous categorical variable based on the name of the groups. Uh, in this case, independent t-test is for the parametric data, and if we want to use the data as non-parametric, we use the Mann-Whitney test that we will explain in another video. The other names for the independent sample t-test here, independent t-test, independent sample t-test. Also we know as between subjects t-test or students t-test. All are the same name for the independent t-test that we can use. And here, for example, you could use the independent t-test to determine whether mean of the measured blood sugar is differed between the group A and group B. We need assumptions to be able to use the independent sample t-test. The first one is your dependent variable should be measured on a continuous scale. Check, we have this one as the blood sugar here, for example, measured in a continuous method. Your independent variable should consist of two categorical independent groups. Check, it's the independent, and you have two categories here. And you should have independence of observation, which means that there is no relationship between the observation in each group or between the group themselves. In the other way, if we want to say it very simple, if we have someone in this group, it's not supposed to be in the other group, and these two groups are exactly two absolutely separate groups. So check, we have this one also. There are three more assumptions that we have also here, but we should check them actually through the measurements in the SPSS. Assumption number 4, there should be no significant outliers, so we should check for the outliers. Your dependent variable should be approximately normally distributed. We should check this one also. And we need the homogeneity of the variance, which we also check this one. After the measuring the t-test, you will see there in the example that we have here. In this example, in a data set that's known as a statistics SAV, that you have it. We have 30 students, and they are participants in this course in 3 different days. Questionnaire measured their fear of the statistic at the start of each day, and recorded under variables FOST, FOST2, and 3. The question we want to answer asking is there is any significant difference between male and female for fear of a statistic in day 1. As you see, we have fear of a statistic in day 1, which is the continuous variable, and we have men and women as the dichotomous and categorical variable that we have. We are going to use it to do the independent t-test. Let's look at the first assumptions that we are going to find out, which is about the outliers and normal distribution, assumption number 4 and assumption number 5. If you want to do it, you just click on the analyze, and after this descriptive statistic, and click on the explore. Here also you can see that, and in this case you will get this explore window, and in the dependent list you put it your dependent or continuous variable here, fear of statistics, and in the factor list you put your independent, which is the gender or sex here, we put it there. And also if we click on the plots here, you will have a new window. In this window, usually the default for the SPSS is a stem and leaf descriptive, but we don't need it, so you take it out, and instead of this you use the normality plots with tests. That is enough for us to check it. Click on the continue and you will get the result first as the a box plot, and in this box plot you need to look at the any outlier that we have here. See, yes, this is our outlier, and whether they have any, maybe they are nothing. So if don't have any outliers, we don't need to do anything. And uh, the outliers SPSS, when we want to measure it, SPSS usually measure the height of this box, and then if the outlier is 1.5 length of the, if it's 1.5a, go down, and if there is any value under this one, the SPSS recognize it as the outliers, and there are usually three different possibility. When we have the outlier, it can be an for example, data entry error, which is a human error. It can be measurement error, also measurement error. It's also a human mistake. It can also be a genuinely unusual value, which we should deal actually with this one. If it's data entry error, we can change it. So if we look at the outliers, two possibility: we can keep it or remove it. If, for example, we can see that's the data entry error, maybe we can correct it, or it's a measurement error, we can also remove it and just continue. But if it's genuinely unusual value, then it's a little bit difficult to decide to put it, keep it, or to change it. If we want to keep this one, then maybe we better to go for the Mann-Whitney test, because this assumption that there is no outliers, and we want to keep it, so we don't reach to this one, we cannot use the independent sample t-test. Or as I said, if we be able to change it, sometimes we ignore it when the samples is big and this is also an unusual value. We keep this one and just go for the independent sample t-test. The other part is test of normality, which is also the assumption number 5, if you remember. And here it depends on which test we are going to take a look. If the sample size is less than 50, which in our case it was 30, then we are using the Shapiro-Wilk test. And the Shapiro-Wilk test, if it's not significant, the assumption of normality met. There is no violation of this assumption, so everything is okay and we can continue. If the Shapiro-Wilk test is significant, is less than 0.05, then we need to go to, for example, non-parametric test, or in some cases you can also transform the non-normally distributed variable to the normal distributed variable, which is not a part of our case that in this lecture to explain. If the sample size is bigger than 50, then we are looking at the Q plot, that you have it also as a something like this with the dots, but based on the dots, if the dots go out, then there is not normal. If the dots all around the line, then it's a normally distributed data. So after that we know about the assumption 4. Assumption 5, we go and do the tests in the analyze. We just remember what we want to do. We want to compare means, and here we know that these are the independent groups, so independent sample t-test, very easy to find based on what we want to do. And then we need to put our data there in the test variable and the grouping variable. Here in grouping variable, we have sex or gender, and then we should define it. And by definition, we are looking at which kind of variable we are putting data entry in SPSS. If, for example, male 1, female 2, or vice versa, based on, or if it's 0 and 1, we should put 0 and 1. But it's very important to be sure that this value is exactly the value that we will find in the variable view. And also we put the test variable, which is a dependent one, fear of a statistic, here, and then we are set and we get the results. In the results also, it's very important to pay attention to the last assumption number 6. That if I just go back and take a look, you can see the assumption number 6 is the homogeneity of the variances, that we are going to have it here by looking at the Leven's test. Leven's test for equality of the variances. And in this case, when we are looking at the Leven's test, we are looking at the level of significance. And if the value that we have here is not significant, like here that we have, then we reach to the assumption number 6. It's okay, and then we can use the level of significance in the first row for the here. Here we can see the value that we need, 0.280, because it's not significant, and so on. Fortunately, SPSS give us also the possibility, if this value, the Leven's test, is significant, then it means that we have now the assumption number 6. Practically, we cannot use the t-test, or the independent t-test, but fortunately SPSS calculate another value here, 0.281, which is not a t-test. Actually, this is the Welsh t-test, which accommodate to the non-homogeneity and give us a valuable result. So in case that the Leven test was significant, then we are reading the second line, which is the Welsh t-test, and we can also report it when we are writing the results.